All right, welcome back, mathematicians. Here is an example of a problem you will see that has to do with Pythagorean theorem. So if I read this problem, it says, when three squares are joined at their vertices to form a right triangle, the combined area of the two smaller squares is the same, right, or equal as the area of the largest square, okay? So combined means I'm adding, right? So if I add the area of my two smaller squares, it's going to be the same or equal to the area of the largest square. And remember, that's what Pythagorean theorem is. Pythagorean theorem says a squared plus b squared equals c squared, right? And so if I take the sides of my triangle and I create a square with them, okay, that's what these diagrams are showing, right? So we need to go through each of these answer choices and pick the correct one that matches a squared plus b squared equals c squared. So if I start with answer choice F, okay, well, if I look here, is a small square, here's a medium-sized square, and here's a larger square. So let's look at what information it's giving us about each square. So on this smaller square, it says 3 centimeters, okay? That 3 centimeters is my side length, right? That's my side length. It's saying one of these sides is equal to 3 centimeters. So if I look at my medium square, this says 4 centimeters. Again, that's my side length, right? It says one side of this square is 4 centimeters. Now, if I look at my larger triangle, it's a little different. It's not 25 centimeters, it's 25 centimeters squared, okay? Remember, anytime I'm dealing with square units, I'm dealing with area. So it's giving us the area of the large square, all right? It's giving us the area, all right? So one way I can set this up is I know that 3 squared plus 4 squared, right? Because my Pythagorean theorem says I'm going to square each side is equal to, now this time it's giving me the whole area. It's already giving me the squared. So I can just set this equal to 25. That's one way I can set this up. Another way would be to find what this one side is equal to. Well, I know if the whole area is 25, so 25 centimeters squared, to find one side, I can take the square root of 25, okay? Well, the square root of 25, I can put that in my calculator and get 5. So what that means is that one of these side lengths, so one of them is 5 centimeters, okay? So another way I can set this problem up would be 3 squared plus 4 squared equals 5 squared, okay? Now let's solve them each way and see if we get the same answers. Those 3 squared I know is 9, 3 times 3 is 9, 4 squared, 4 times 4 is 16, equals 25. If I add 9 plus 16, I get 25, which is in fact equal to 25. All right, let's see if we get the same thing here. So 3 squared, 9 plus 4 squared is 16 is equal to 5 squared, which is 25. And if I add 9 plus 16, we get 25 equals 25. All right, so this one does in fact match what our diagram shows. So let's just go and double check and make sure all the other ones are wrong. So if I'm looking at this one here, right? So this is answer choice H. So I'm looking at answer choice H. So I've got, here's my 3 squares. So again, I'm going to start with my smaller square. It's saying 9 centimeters. So it's giving me the side length, right? Because it's not squared units. It's just single centimeters. But however, my medium one is giving me square units. It's saying 144 centimeters squared. So again, it's giving me the whole area, okay? So one thing I can do is find first what one of these sides is equal to. Well, I know in order to do that, all I need to do is take the square root of 144, okay? If I take the square root of 144, I get 12, okay? So this side length right here is 12 centimeters because 12 times 12 equals 144. All right, and then on my larger square, it's giving me this side length, right? Because it's just 21 centimeters, okay? So if I set this up, 9 squared plus 12 squared, right? Because my side length was 12, equals 21 squared. All right, so 9 squared is 81 plus 12 squared is 144 is equal to, I'm going to have to take out my calculator. What is 21 squared? All right, is 441. All right, 21 times 21, 441. All right, now if I take 81 and I add 144, I get 225. Okay, is 225 equal to 441? It's not, so our answer cannot be H. All right, now let's look at answer choice G. So answer choice G, if I look at my 3 squares, each one of those squares, it's just giving me the side length, right? Because it's just centimeters. It's not centimeters squared, so it's just these sides. Okay, so this side is 5 centimeters. This side is 12 centimeters. And this side is 13 centimeters. Okay, so if I plug these sides into my Pythagorean theorem, it would look like this. 5 squared plus 12 squared equals 13 squared. All right, so 5 squared, or 5 times 5, is 25. 12 squared, or 12 times 12, is 144, is equal to 13 squared. Let's do that real quick. 169. All right, so 25 plus 144 is equal to 169. Which is in fact equal to 169, right? 169 equals 169. All right, so far F is correct and G is correct. Now let's look at J. So J, this small square is saying this side is 6 centimeters. My medium, it's giving me the area. So again, it's giving me the area of the whole square, right? Everything inside the square. So to find what one side is, I'm just going to take the square root of 64. So the square root of 64, I know, is 8, right? So this side is 8. If I go to my larger square, again, it's giving me all the area inside my square, it's saying is 100 centimeters squared. So to find one side length, I'm going to take the square root of 100, which is 10. And so this side right here is 10. All right, so if I plug it all into my Pythagorean theorem, so my 2 smaller squares, so these 6 squared plus 8 squared is equal to the larger square, 10 squared. All right, so let's square it all. So 6 squared is 36. 8 squared is 64. and 10 squared is 100. All right. And if I add 36 plus 64, we get 100, which is in fact equal to 100. So this one is also correct. Now, I made a mistake when I read this problem, and this is a common mistake that we all make all the time. The question is asking which three squares do not support this statement. So we were actually looking for the three squares that are incorrect, or the one that does not give me the same number on each side of the equal sign. So if I look, the only one that does not support our statement or support our Pythagorean theorem, which is a squared plus b squared equals c squared, is answer choice H.